we're going to pull out some amazing wisdom that's not just about code, but about the tools we all use to build great things as a team.
You've heard this a million times, right? It's this idea of the master craftsperson with their own personal, perfected set of tools. But what if, for the giant, messy, team-based projects we all work on today, that bit of classic wisdom is actually completely wrong? So, let's dig into the first big problem Brooks identified. He called it the private toolbox problem. It's this tendency for even your most brilliant experts to kind of hoard their own special tools, which in the end actually hurts the whole team. And Brooks lays out this really fascinating contrast here. On one side, you've got that lone craftsman with a locked toolbox. It's a symbol of their individual skill. But he argues that for modern projects, the single most important thing isn't individual genius, it's communication.
He says this whole individualistic approach is just foolish. For one, it puts up walls right when you need to be talking to each other. Plus, let's be real, in tech, that perfectly customized tool you spent 6 months building is going to be obsolete pretty fast. At the end of the day, it's just so much more efficient to build a powerful, shared toolkit that everyone can learn and improve together.
Okay, so what's the fix? Well, according to Brooks, it's not just about buying everyone a license for the latest software. The real and much harder job of a manager is to create a philosophy of tools, a whole strategy for how they fit into the work.
And this philosophy is all about striking a very specific balance. A manager needs to provide that rock-solid common foundation of tools that everyone can count on, but, and this is the key part, they also have to empower their teams to build their own specialized tools when they need them, and not make them feel like it's a waste of time.
Now for the fun part. Let's get into the trenches and see how this all played out with two amazing stories from IBM's OS/360 project, which was, one of the most complicated and ambitious software projects in history.
So put yourself in the manager's shoes for a second. For months, you've had these brand new, unbelievably expensive computers just sitting there, barely being used. And then, bam, seemingly overnight, everyone needs to use them all at once, and you've got a massive crisis on your hands. And this chart really shows you what happened. That demand wasn't a gentle slope, it was a vertical cliff. Why? It's simple, really. Everyone hit the debugging phase for their first components at the exact same time. From that day forward, the machines were slammed. Now, management's first instinct was the logical one. Create this super efficient central schedule to maximize every last second of machine time. And it was a complete disaster. It just led to tons of waiting and frustration. The real solution was kind of counterintuitive. Give a team a whole machine for a solid 4 or 6 hour block and just let them run with it. Machine usage might have dipped a bit, but programmer productivity went through the roof.
And as Brooks points out, this just proved something programmers have always known. That super focused, uninterrupted work you get done late at night, the graveyard shift, it's always been the most productive time. This new scheduling system just figured out how to make the graveyard shift happen from 9 to 5.
All right, story number 2. And this one, man, this is a problem that every big project still struggles with today. How do you take code from hundreds of different people and put it all together without the whole system just constantly catching fire?
Their solution was absolutely brilliant. It was a 3-level system. So, every programmer had their own private playpen where they could do whatever they wanted, no restrictions. When their piece was ready, it got promoted to a controlled integration library. And then, only when a whole build was stable, did it move to the final, sacrosanct release library that everyone else used.
And this wasn't just some nice little idea. Brooks himself called it one of the absolute best executed parts of the entire project. He didn't even call it a process, he called it a piece of management technology. That's how crucial it was.
Okay, so finally, let's look at 2 tools Brooks saw as the real future of programming. And what's so interesting is that they didn't even really use them on OS/360, but he knew they were the sharpest tools in the shed.
First up, using high-level languages. For Brooks, this was an absolute no-brainer. The benefits were just overwhelming. It's not just about writing code faster, it's that you create way fewer bugs to begin with. And the ones you do make are a whole lot easier to find and fix. And the second big one was interactive programming. This goes right back to that first story, right? It's a direct attack on what he called the bane of debugging, that painfully slow turnaround time. An interactive system gives you that fast, constant back and forth with the machine.
And look, he wasn't just guessing. He had the data to back this up. Check out these numbers from Bell Labs. The programmers who were using conversational or interactive systems were pumping out 8,000 instructions a year. The old-school batch programmers, they topped out at 4,000. It's not even close.
I mean, the takeaway from these numbers was crystal clear. A good interactive system wasn't just a small improvement, it could literally make a team at least twice as productive. That's huge.
So after all these years, what's the one timeless lesson we can pull from all this? I mean, this isn't just about software from the 60s. This applies to building basically anything today.
And it all comes down to this one crucial point. The best teams don't just have smart people with cool tools. The best teams have a strategy. They are incredibly deliberate about what tools they use, why they use them, and how it all helps them work better together.
Which brings us to the final question, and this one is for you. It's easy to list off all the tools your project uses. That's the simple part. But can you explain its philosophy? Can you explain the strategy behind them? Now that's the question that really gets to the heart of it.